Okay, Bismillahirrahmanirrahim. So, in the last lecture, we talked about doubly linked lists and circularly linked lists, and we looked at the implementation of doubly linked lists in C++. And we talked about what is the difference between a circularly linked list and a singly linked list, or how you can convert a singly linked list into a circularly linked list. And I left the implementation of a circularly linked list as an exercise for you. Like, you can work on that and you can see how it pans out. In this lecture, we are going to talk about these three data structures: the stacks, queues, and double-ended queues. So we have mentioned these data structures before as well. These are perhaps the most famous data structures that we have that are very widely used, especially the stacks and queues, and they are easy to implement, and their behavior is also very easy to study. And these are some things that we come across commonly in our daily routines, so it's very easy to understand and implement these data structures. A double-ended queue, it's similar to a queue, but it is a double-ended queue. That means the operations that can take place in a queue, those operations can take place at both ends of the queue of a double-ended queue. So we will study what a double-ended queue is. So let's get started. So first of all, let us talk about the stack data structure. So the stack data structure, as we have mentioned, like we have talked about different examples of the stack data structure, and one of those examples was a plate dispenser. If you have gone to a restaurant or to a buffet, so there you have the dispenser for plates, and those plates are stacked in that dispenser. You pick up a plate from the top, and then the plate that is immediately below that plate, the top plate, it comes to the top. Okay, then you pick another plate from the top, and the one that was below that plate, that comes to the top, so on and so forth. So you can only take plates from the top, and new plates or clean plates can be inserted at the top as well. Okay. So the stack data structure, insertions of new data or new nodes and deletions of existing nodes, they follow a scheme that we call last in first out. So whatever comes in last, that has to go out first. Okay, so this plate, it was inserted at it was the latest plate, or the last plate that was inserted on this dispenser. This was inserted before this one, and this one was inserted before these two, and this was the first plate that was inserted in this dispenser. So this plate would go out last at the very end, and this plate which was inserted at the very end, it was going to go out first. It is going to go out first. So this is a last in first out, or LIFO data structure. Okay, last in first out, or LIFO data structure. So stack is such a data structure. So you can think of it as a plate dispenser, you can think of it as the magazine of a pistol or something like that. So the main operations of stack are the push operation. It is called push because usually these structures, like the plate dispenser and the magazine in a gun, so these are spring loaded. So you have to apply force to insert new data into those dispensers or something like that. So it is called this operation is called push. If you want to insert a new node or new data or new element on the stack, you say push this element on the stack. We use the term push for that. So push is basically inserting a new node or new element on the stack. And when you take something out, so it basically pops out. Okay, so since this is spring loaded, so the spring applies force in this direction against the weight of the plates. So the plate or the bullet, it pops out, it pops off or pops out. Okay, so pop operation, we call it, is the operation that is basically removal of the last inserted element on the stack. Okay, then the element that you inserted last, that has that is basically removed. So removal and insertion it take place at the top of the stack. There is just one location on which the insertion or pushing of new nodes and the removal or popping of existing node that takes place. So these are the main stack operations, push and pop. And then there are some auxiliary operations as well. Like you should be able to look at the top, access the top element. Okay. So when you call this method top, it would return you the last inserted element without removing it. So you'll just be able to read the data stored on the top, something like that. Okay. Size of the stack. So how many elements are in the stack? So this method would return you that. And is empty or empty. This method would tell you whether the stack is empty or not. Okay. So this is basically the stack. It is a data structure which follows a last in first out scheme. The last element that you insert into this data structure, that is the element that would be removed first. That is what last in first out means. Okay? Or first in last out. You can also call it as first in last out. So whatever comes first, that goes out last. Last in first out or first in last out. Okay? So stack is basically this thing. It follows the scheme. So example is when you think of the stack, visualize a spring loaded dispenser, plate dispenser or bullet dispenser. Okay, so you can imagine both of these. And the main stack operations are push and pop. Push basically pushes a new object onto the stack, and pop removes an existing object from the top of the stack. Okay? The last element or object that was inserted on the stack, that was pushed on the stack, that is removed. Then we have the auxiliary top, auxiliary method top. It would basically return the top element stored on the stack. It will not remove it, just give you the data or some way of knowing what is at the top. You can find out the size of the stack and whether the stack is empty or not. Okay, so this is what the stack's interface is going to be. When we are going to implement the stack, we are going to provide at least 1, 2, 3, 4, 5, 5 of these methods, excluding the constructor and destructor. Excluding those, we are going to provide or implement these 5 methods. Okay. So stack interface in C++, how is the stack class going to look? So the stack class is going to look something like that. Here we are talking about exceptions. Exceptions are basically the C++ way of uh, exceptions are basically errors. Okay, exceptional situations. So normally we think normally the code would be behaving correctly, and there may be exceptional situations. So we are not using exceptions. We're basically keeping things simple. But in any professional code, you should be using exceptions. And whenever there is an error, you should indicate that there is an error. But right now we are not doing that. Okay, so we are going to stick to this very simple interface. These are the main functions that the stack class should have, and these are the auxiliary functions that we are going to provide. So when we implement the stack class, it is going to have at least this interface. Okay. Okay. So what are the applications of stack? Again, we have talked about the applications of stack. It is used. It is a very important and very useful data structure that is part of many applications. For example, your browser, it needs to keep track of all the pages that you have visited. Okay, so when you want to go back to the pages, the most latest page that you visited, so the browser maintains a stack. So any page that you visit, it pushes that the URL of that page onto a stack. So if you click any link in within that page, you go to a new page, and the URL of that page is pushed onto the stack. Okay. So once you decide to go back to the latest page that you visited, you can press the back button on your browser, and that button would basically result in popping off the topmost URL from the stack and taking you to that web page. Okay? So we have talked about this. This is one important application. The other is the undo sequence in text editors. So whether it is Microsoft Word, PowerPoint, Excel, WordPad, Notepad, or any editor for that matter, which allows you to enter text and do things. So, or any other application, it provides you with the facility of undoing the last action, or undoing the last 100 actions or 10 actions or 20 actions, whatever it is, depends upon the application. So that facility also uses stacks in the background. Whenever you perform an action, so that action is encoded in some form and it is pushed onto a stack. So you have a stack of actions, okay? Or you can call it as maybe the action stack. So the action stack keeps track of your latest action, okay? Your latest action. So whatever you do, your latest action, it is pushed onto the stack. So after working on in a software or on a software for some time, you will have a certain number of actions performed in that software. And if you decide to undo those actions, so you can start popping off actions from that action stack, and the software can start undoing those actions. Okay. So this is also very important. This is something that you use very often, almost all the time in any software that you use. So this functionality is provided by Stack. So whatever you're like learning about data structure, this is not something that is useless. It is very useful and very extensively used in different software. Next is the chain of method calls in the C++ runtime system. So when you're writing programs in C++, so you're calling one function, then that function may call another function, that function may call another function. And all these functions, they know where to return. Once they are done executing, they know where to return. So that is also implemented. This functionality is also provided by using a stack. So there is a stack of, say, function calls or function activation records. And whenever you call a new function, so an activation record for that function uh, or a frame related to information to that function, that frame is pushed onto the stack. Okay, it is slightly more complicated than that, but the basic idea there is that you use a stack data structure to store the return addresses. So when you're done executing the function that you called, you should know which address to return to, and you should also store the values of the local variables of the caller function. So when you return to the caller function, all the variables, local variables in that function, they should have their original values. Okay, and you should also be able to pass arguments to the callee functions. So all of this is done using stacks, using the stack data structures, which the C++ runtime maintains internally. Okay, and then there are indirect applications of stacks as well. So stacks are used as auxiliary data structures. They may be used as auxiliary data structures for implementing different algorithms. We'll talk about some algorithms. For example, the simple balancing algorithm. They may be components of other data structures. Okay, so that they can also be used in this way. This is the example of the C++ runtime stack. This thing that we talked about. So say for example you are in the main function, and from the main function you call the function foo, okay, and then the function foo calls the function bar. So once the bar function is executed, then you should return to the function foo, and once the function foo is executed, you should be able to return to the main function. Okay, so that is what happens when you call function foo from the main function. So the values of all the local variables in the main function that are pushed onto the stack, and the value of the address to which you have to return after executing function foo, that address is stored onto the is pushed onto the stack. So this is PC or program counter. Okay, so program counter is basically, it keeps track of the statement that has to be executed the next time. Okay, it keeps track of those statements. So all the local variables and the return values, if function foo needs to return some value, so that value all these things, sorry, when when we call function foo from the main function, so all the local variables in the main function and the return address, uh, the address of the instruction which has to be executed after foo function is executed, that is pushed onto the stack. So once you enter the function foo, here we function foo calls the bar function. Okay? So that means all the local variables here, their values need to be stored. So we need to store the value of k and j. We need to push that onto the stack, and we need to store the value for the program counter once this function bar is executed. So which instruction should be executed? The address of that instruction, it also needs to be stored. So these are some dummy values. These are not the actual addresses of those instructions, but these are some dummy values inside the bar function. So once the bar function is called, so the bar function, it also needs to know the address of the program counter, or once this function is done executing, so which address should you return to or should you jump back to? Okay? So that address needs to be stored, and similarly the argument that the bar function works on, so that argument is also passed to the bar function. So once the bar function is executed, so these variables this would be destroyed, and this address would be loaded into the program counter register. Okay? So that is the register inside your microprocessor, which basically tells you which instruction is going to be executed, and this entire frame is going to be taken off the stack. So once foo function is done executing, these local variables will be destroyed, and the program counter register will be loaded with this value, and this frame will be taken off the stack once the foo function is executed, and we return to the main function. Once we return to the main function, so once the main function is done executing, then these local variables inside the main function, they will be destroyed, and the control would return to operating system, some place inside your operating system. Okay, so this is how the C++ runtime stack works. This is approximately how it works, and it also allows for recursion. Recursion is when a function calls itself again and again. Okay, so the C++ runtime stack. Sorry for the delay. The C++ runtime stacks, it allows for recursion as well. Okay, so recursion is possible because there is a stack, and in fact function calling is possible because we are using a stack. Otherwise, like, we won't be able to use stacks. Okay, so I hope like you understand it, and I hope you had some idea of it from computer programming. I'm not sure, but maybe you had some idea from there. If you don't have, so this is how it works. Acha. So this is basically a frame. This is a frame. This is a frame of data of all the local variables and return addresses. So when one function calls another function, so a whole frame of data is pushed onto the stack. Okay? It is also called activation frame or something like that. So you can look up all this information. I just wanted to give you some idea. This is another application of stacks, and this application is also important, parenthesis matching. So normally when you write a code, for example, if you're writing a class definition, and you say class, and then you provide the name of the class, and then you write this opening curly brace, for example, so automatically a closing curly brace, and this thing appears. If somehow you provide an extra curly brace, opening curly brace here, or something like that, so now we have two opening curly braces and one closing curly brace. These should match. Like, we should have the same number of opening brackets and the same number of closing symbols or brackets. Okay, so this problem is called parenthesis matching. Like, the compiler, when it's compiling your code, it always does parenthesis matching. It needs to know like you have provided the same number of opening and curly braces. Okay? If you are using these parentheses, so the number of opening parentheses and closing, they should match. The number of opening and closing curly braces should match. The number of opening and closing square brackets, they should all match. Okay? For example, look at these expressions. So here we have opening curly brace and then a corresponding closing curly, sorry, opening parenthesis and closing parenthesis, then two opening parentheses, then corresponding to closing parenthesis, then a closing curly brace, opening parenthesis, opening square bracket, opening parenthesis, and then we have in the same order like this is the innermost symbol, so opening symbol. So the innermost closing symbol, it should match this one. Similarly, these two are matching, these two are matching, and these two are also matching. So this expression, if any expression uses this thing, these symbols in this order, this is correct. Similarly, you can verify this is also correct. And look at this one, this is not correct. Like an expression never starts with a closing symbol. It always starts with an opening symbol. So this is incorrect. And rest, this is correct. These two are balanced. This is outer, inner, yeah, these are also balanced. The only incorrect symbol is this one. Okay. Similarly, if you look here, so here this is the opening symbol, the first opening symbol. So here the last one should be a closing parenthesis, but it is a closing curly brace. Okay, so this is incorrect. But how would you find out? This is also incorrect. How do you find out? How are stacks used for this thing? So this is the algorithm for parenthesis matching. Okay. So how does this algorithm work? So algorithm takes this input. It gets an array of n tokens. Okay, so token is basically a string. So a symbol, an individual symbol or a group of symbols. Okay, but those symbols should be like contiguous. So what are we going to do here? So the symbols can be variables, they can be arithmetic operators, they can be maybe keyword. Sorry, in expression we don't have keywords, so we may have keywords. Maybe we may have keywords, but usually they are variables, arithmetic operators, numbers, or they can be these grouping symbols. They can be these grouping symbols. These are the grouping symbols that we are talking about. Okay. So all these brackets, opening and curling brackets, they are basically used to group symbols, okay, into different groups. So these are our grouping symbols. Now we are going to ignore the variables, the arithmetic operators, and the numbers. We are only going to focus on these grouping symbols. Okay? Acha ji. So how is the algorithm going to work? So if you find an opening grouping symbol, a symbol like this, if you find any opening symbol, these are opening symbols. Okay? Opening grouping symbols. If you find any of these simple symbols, just push them onto the stack. Push them on the stack. Okay? Keep on pushing them. Like if you look here, so opening symbol, push it onto the stack. Opening symbol, push it onto the stack. Opening symbol, push it onto the stack. Now this is a closing symbol. So you don't push it onto the stack. You keep it with you, and you pop a symbol from the stack, off the stack. You compare the two. Do they match? Yes, they do. So fine. ठीक है. Next token. This is an opening symbol. ठीक है. Push it onto the stack. This is opening. Push it onto the stack. This is closing. ठीक है. So जब closing symbol मिले, you don't need to push it onto the stack. You just pop the last symbol that you pushed onto the stack. Compare the two. Do they match? Is this the corresponding opening and closing symbols? Yes, they do. ठीक है. Get rid of the two. Now, again we have a closing symbol. Acha. What should we do? Pop a symbol off the stack. Do they match? Yes, they do. Ignore the two. Next, opening. Push it onto the stack. Opening, push it onto the stack. Opening, push it onto the stack. Opening, push it onto the stack. Then we come across a closing symbol. Then pop the symbol that you last pushed onto the stack. Do they match? Yes, they do. Ignore them. Closing symbol. Okay? So pop another symbol off the stack. Do they match? Yes, they do. Ignore, get rid of them. Another. Okay? So then you pop a symbol off the stack. If they match, fine. Then another. Then you pop a symbol off the stack. If they match, fine. So once all the tokens are finished, the stack should be empty. Once all the tokens are finished, the stack should be empty. ठीक है? So अगर opening grouping symbol है तो उसको stack पे push करते जाएं. अगर closing grouping symbol है तो if the stack is already empty तो इसका मतलब ये है कि we don't have a corresponding opening symbol to match, so this expression is not correct, so you return false. And if the symbol that we popped up, if it does not match the opening symbol, you also return false. The symbols do not match. And if the stack is empty, ठीक है, तो we return true. ठीक है कि तमाम stacks जो हैं वो नहीं. Yes. So if the stack is empty, this is what we do in the end. ठीक है. This is what we do. अच्छा, इसमें वो हम कहाँ पे compare कर रहे हैं? अच्छा, I hope like you have understood this example जो कि यहाँ पे explanation दे रहे हैं कि you pop this, अगर वो match करते हैं तो बस then fine, you return true. यानी आपने you found a closing grouping symbol और फिर आपने stack से एक symbol को pop किया and these two symbols matched, यानी यहाँ पे आपको closing parenthesis है तो वहाँ पे opening parenthesis आपको stack से मिला. So then they match. अगर आपको square bracket मिलता है और यहाँ पे ये closing parenthesis है तो then they do not match, then you have to return false. But in this case you can return true and things are fine. ठीक है? So you can look at this algorithm, and this algorithm would basically do parenthesis matching for you using stacks. Now this is a very interesting application of stacks. इसके अलावा भी और बहुत सारी applications and stacks की, we do not have time to cover each and every application, but these are some of the interesting applications that you can look into. Now we are going to implement the stack as a linked list. ठीक है? We can implement a stack as a linked list. We can also use arrays to implement the stack. So you can have an array based implementation of the stack. In fact, this book by Michael T. Goodrich and Roberto Tomassia, so they provide a stack based implementation of, sorry, an array based implementation of stacks as well. So you can look at that code. Okay? You can look at that. Now इसमें linked list में क्या था? Single linked list में, so we had the first node. So now the first node would be the top element, and we are going to insert new elements only at the first position. See, ठीक है? So इसका मतलब linked list में तो हम किसी भी kth position के बाद insertion कर सकते थे. ठीक है? Singly linked list में the first implementation of the singly linked list, there we could insert a node after the kth position. ठीक है? तो यहाँ पे हम सिर्फ insert करेंगे nodes को after k is equal to 0. ठीक है? यानी first position, यहाँ first position पे हम nodes को insert करते जाएंगे. So that because in a stack, insertions and deletions they always take place at the top. ठीक है? So the बिल्कुल beginning पे हम करते जाएंगे. So this is the first node that was inserted. ये दूसरी नंबर पे insert हुआ तो ये तीसरी. This was the latest. This is the latest node that, or the last node that was inserted. ठीक है? And this appears at the top. This appears at the beginning of the stack. ठीक है? At the top of the stack. So now we are going to use the terminology of the stack. So you can use singly linked lists to implement a stack, and that is what we are going to do in this lecture. Similarly, let's talk about the other data structure, the queue data structure. Queue या कतार, जिसको हम उर्दू में कतार कहते हैं. So this is also a data structure, and you know, like in queue, कतार में, say for example this is a कतार, इसमें लोग खड़े हैं. ठीक है? और कतार कहाँ पे बनती है? So whenever you have one service provider, say this is a bank for example, sorry ये इस साइड पे ये होना चाहिए. So say this is a bank and this is a bank employee, who is serving all these people, and this is just one employee who is providing this service, and we have many people. So when we have many people, those people have to queue up. वो एक line बनाएंगे, कतार बनाएंगे, ठीक है? So pardon my drawing, I'm doing it using a mouse, so this is not very good. So any new person who comes or enters the bank and needs this particular service provided by this particular individual, so that person has to stand in this queue, okay, and he has to stand at the back of the queue or at the rear end of the queue. So this is back of the queue and or the rear end of the queue, okay. So new people, new arrivals, they happen at the rear end of the queue, and people are served at the front end of the queue. Once a person is served, so that person gets is taken off the queue. जब उसका काम हो जाए तो उसको हम queue से हटा देते हैं. So this is the front of the queue, ठीक है? So front of the queue, rear of the queue. So we have 2 points. Deletions occur at the front of the queue. When a person is served, that person is taken off the queue. It is removed off the queue. And new people, they arrive at the rear end of the queue. So we have 2 different ends, ठीक है? And this is the first in first out structure. First in first out, FIFO, ठीक है? जो बंदा पहले आया है वो उसको पहले सर्व किया जाता है. और लास्ट इन लास्ट आउट, लीलो, ठीक है? जो बंदा आखिर में आया है वो उसको आखिर में सर्विस मिलेगी. लास्ट इन लास्ट आउट, ठीक है? So this is a FIFO or a LILO structure. Insertions are at the rear end of the queue and removals are at the front end of the queue. So main जो operations हैं queue के वो क्या है? NQ. NQ, when new person arrives in the queue तो वो कतार में लग जाता है. NQ means कतार में लगना, ठीक है? So what happens here? Inserts an element at the end of the queue. So that is what happens in the NQ operation. And DQ means कतार से निकालना, कतार से निकलना या निकालना. So DQ happens at the front. When a person is served, that person is taken off the queue. ठीक है? So these are the main operations of the queue, and these are the auxiliary operations. You might want to know who is at the front of the queue, who is at the back of the queue. ठीक है? We might want to know who is at the back. I didn't write it, but we can have a back or rear method. So if you are interested who is at the back of the queue, so we can have that method as well. Okay, we'll provide that as well. We can have size of the queue. कितने लोग मौजूद हैं इस वक्त. This is also important property, and we can have a method is empty or empty that would tell us whether the queue is empty or not. ठीक है? So this is how the queue structure would look. Now these are the example operations. For example, we start out with an empty queue. So उसमें आप data in queue करते जाते हैं. So NQ5, so the queue would look like this. This is the front of the queue. ठीक है? ये queue का front है और queue का जो rear है that would be this side. So then we NQ3. So 3 उसके पीछे लग जाता है. ठीक है? So this is how the queue would look. Then we DQ. So you DQ means you don't specify anything. You just DQ an element from the front of the queue. So 5 is removed. Then we NQ7. So 7 appears here. Then we DQ. So 3 is removed. Now we just have 7. If you want to know about the front would be 7. If you DQ, so 7 भी DQ से remove हो जाएगा. And now we have nothing. If you DQ an empty queue, so you should get an error. ठीक है? If you call the empty method for this queue, so you should get true. If you start in queuing, so this is how it would look. Okay, so this is basically example operations of queues. Now, what are the applications of queues? So queues are also widely used. Number all waiting lists, whether those waiting lists are for messages or emails or any web traffic or calls, or whether those waiting lists are in the bank. For example, when you go to the bank and you go and get a ticket for yourself, ठीक है? So then you enter a queue, and when a person in the bank it serves a particular customer, then it presses some button so to get the next person, next customer in the queue. Okay, so waiting lists, they use queues, and they are used in like almost everywhere. Access to shared resources, they also have queues. For example, your printer, it has a queue, it has a print queue. So we all send jobs to the printer, and those jobs they enter a queue. The first guy who pressed the print button, सो दिस इज कॉल्ड अ प्रिंट क्यू. ठीक है. सो उसकी जॉब सबसे पहले होती है उस क्यू में, एंड देन द अदर जॉब्स बेस्ड अपॉन at what time they arrive in the printer's memory, so they enter the print queue. Multi-programmer, whenever like we used to have a single CPU, and we wanted to run multiple programs on that CPU. So this is basically multi-programming. Nowadays uh, we have systems with multiple CPUs, or we have multi-core systems. Okay? So even then, like multi-core systems, the most cores that we can have, we usually have maybe around 8. So even if you have 8 cores, you're still running more programs or softwares or processes than the number of cores that you have. अच्छा, पहले इसको समझ लें. For a single CPU, so if you have a single CPU, assume this is your single CPU and you want to run different programs. For example, right now I'm running Microsoft PowerPoint. ठीक है. I am running OBS Studio. I have code blocks running. I have say, I guess the browser is also running, and then there would be other services related to Windows that would be running. Now how does the CPU, it is just one CPU, say for example, and it has to run all these programs. So how would it run this program? So what happens is that your operating system, the Windows operating system, it maintains a queue of processes that the CPU has to run, and this queue operates in a round robin fashion. So for example, right now this is a PowerPoint is at the front of the queue, so it runs PowerPoint for say uh, a couple of milliseconds, say for example 100 milliseconds or 50 milliseconds, and then when it is done running Microsoft PowerPoint, it pushes it to the rear end of the queue. Okay? Then it would run, say for example, OBS Studio for a couple of milliseconds or microseconds, depends upon the operating system, and so it would then push it to the end of the queue. ठीक है. So ये राउंड रॉबिन फैशन में ये तमाम जो एप्लीकेशंस होती हैं इनको ये बारी बारी रन करता है, और सबकी बारियां जब हो जाती हैं तो फिर सबसे पहले वाली की बारी फिर आती है. ठीक है. सो दिस इज हाउ इट गोज. So queues are extensively used by your operating system. Then again, it can have indirect applications as well. You can use queues as part of other, in order to implement other algorithms, or they can also work as parts of other data structures. ठीक है. So this is the scheduler. Scheduler is basically part of the operating system, or the component of the operating system that schedules the execution of different programs. So how does it happen? This happens in a round robin fashion. That means कि ये जो प्रोग्राम है, या ये जो सर्विस है, या जो भी चीज़ है, एप्लीकेशन है, when it is executed by the CPU, ठीक है. So sorry, this is the front of the queue. ठीक है. This is the front of the queue. So when this application is executed by the CPU for a finite amount of time, तो इसको front of the queue से उतार के यहाँ back of the queue में फिर लगा दिया जाता है. ठीक है. इसके बाद फिर ये फ्रंट पे आ जाता है, दिस वन. सो इसको फिर एग्जीक्यूट करके फिर इसको बैक ऑफ द क्यू पे लेके चला जाया जाता है. फिर इसकी बारी आती है, फिर इसकी जो पहला वाला जिसको हमने एग्जीक्यूट किया था और फ्रंट पे लगाया, फिर वो फ्रंट पे आ जाता है. सो इन अ राउंड रॉबिन फैशन, जिसमें सबकी बारियां बार बार आती हैं, these applications are executed, and this is done using a queue. ठीक है. So I want you to understand first all the data structures, and then we'll go to the implementation part. So we can also implement a queue as a linked list, and we will have two pointers. One we will maintain for the front of the queue, and the next we'll maintain for the rear end of the queue. So new items would be inserted at the rear end, okay, and dequeue operation would take place at the front of the queue. Okay. So this is how the items would be connected. The links would be created. So remember this thing, and then we will, when we are implementing it, so we'll come back to this figure and see like how to implement it. And last, the data structure that we want to talk about is the double-ended queue. In the double-ended queue, it is basically a queue data structure. Okay? It's just like a queue, just like this thing. But in a queue, like the nodes are removed from the front, or DQ operation take place at the front, DQ operation take place at the front, and NQ operation take place at the rear. Now if you have a queue where you can NQ and DQ both at the rear end and at the front end, मतलब जैसे आप बैंक में जो है ना, if the last person decides कि मैं जी और इंतज़ार नहीं कर सकता, I want to go, I want to leave, so that person should be able to leave, ठीक है, this person should be able to leave. अच्छा, एंड बाज़ औक़ात बुज़ुर्ग शहरी आ जाएं कि जी वो इंतज़ार नहीं कर सकते, so then emergency में we can NQ a person here at the front as well. So we should be able to NQ a person at the front, and we should be able to DQ a person from the back. So that is a double-ended queue. That is a double-ended queue, and it has its own uh, importance and applications. Now, if you remember our implementation of the doubly linked list, so it was exactly double-ended queue but with different names. Like we could insert it front, insert it back, remove it front, remove first, remove last. So it was exactly double-ended queue, and we implemented it using doubly linked list, and it provided all. But हमने वो नाम वो वाले use नहीं किए. But you can go with those terminologies as well. You can, like, instead of saying in queue at front, you can say insert at front, or insert at rear, or insert at back. You can use those terms as well. ठीक है, so उसमें कोई issue नहीं है. Asha, so I hope like you're clear about the stack, the queue, and the double-ended queue. We have done the implementation of the double-ended queue. Our implementation of the doubly linked list, it was basically an implementation of the double-ended queue data structure. Okay, so that was 2-in-1 for me. And now in this, the remaining part of this lecture, we are going to implement the stack and the queue. So let's write some code. Okay. So let's come here to the code blocks and let us create an application, and let us, ठीक है, इसको नाम देते हैं जी, this is a project, and let us implement stack and queue. ठीक है, हम stack piece में implement कर रहे हैं और queue piece में implement कर रहे हैं. अच्छा, in a single project. ठीक है, so this is what we have. Now we need to declare the interface of our classes, so let's add a header file to do that. Let us skip this page the next time. Okay, so let us name this file as my classes. This is how I name it. Okay, so here we are going to define declare two classes. One would be the stack class. Let us call it, like, we have a stack class in C++ somewhere. Okay, so we want to make it a little different, so let us call it as my stack, or C stack, or our stack. Okay, so let us call it, say, C stack. Okay, C++ stack. So this is, say, C stack. I want this name just to be different from the ones that may be available to us already. Okay, this is the stack class. Similarly, this is the Q class. So Q, already we have some class by the name of Q. Okay, spelling small q say this is from capital Q. You can have it that way, like you can say, or you can just call it CQ. Okay. Acha. And both these stack and Q classes, they will have nodes. Okay. Let us call them nodes. They will have nodes or elements. You can call it element or node, whatever you want. Node has fewer letters, so let us call it as node so that we don't have to type a lot of letters all the time. Okay. Now both the C stack class and the CQ class, they will be friend classes of the node class. So class friend class C stack. Okay, and friend class C So we want both these classes to be the friend classes of this class. Okay? And what are going to be the data members of it? You don't need to write private explicitly. It's always by default private. So data members are going to be int data, and then we need a pointer to a node object, and that would be next. Okay? Pointer next. So it is going to be, we are going to implement it using a singly linked list. So in a singly linked list, all the nodes have information about just one other node. Okay? So this is how it's going to look. Now the C stack class. So we have the interface for the C stack class. Here it is. Let's get back to it. Okay. So these are the mandatory operation: void push and void pop. Okay. So these are the mandatory or essential functions. So these are going to be public. One is void push. Okay. And we are going to specify new data. So, and data is going to be in the form of integer value, int x. Okay. And we can have a reference, say save some space, const int x. It doesn't make any difference if the ampersand is here or here. It doesn't make any difference. Maybe it makes it a little more clearer. We can put it either way. Okay. So this is push. Similarly, void pop. So acha, void pop here. So this would remove the topmost element. Okay, void pop. We don't need to pass anything. Sure. You can make changes to it if you want to return the value that you're popping. You can do that. So these are the essential functions. We are not going to throw any exceptions. Okay. Acha. Next, the auxiliary methods. So size, empty, and top. Size, empty, and top. So void int size. So, or get size. Let us call it, say, get size. This would be a const function. Okay, get size. It would return the size. Then is empty. So bool is empty. Okay. So let us make it const as well. Then top, we want to get the top element. Okay. Achha ji. We want to get the top element. So we are going to return the value stored at the top. So let us make it as an integer. Int top. Okay. Int top. And let us make it as const. So this would return the value at the top. Achha, what else? I guess we have to provide a constructor function, C stack. This is the constructor function for C stack. And we also need to provide the destructor function. Okay. C stack. We also need to provide the destructor function. Okay, this is the public interface of the C stack class. Now internally, in order to implement it, we need to do something. First of all, we need to keep track of the top. Okay? We need to keep track of the top. So we need to have a node pointer that would basically T. Let us call it T. That would keep track of the top. This would point to the top of the top node in the list, in the linked list, or in the stack. Okay? Let us call it a stack. So it would store the address of the node at the top of the stack. One, and then int size. So let us use the variable list size for that. Okay, int list size. So this would basically keep track of the size. Okay. Okay, so this is basically the cstack class. Cstack class. Uh, let us do something similar for the Q class. So this is how the Q class is going to look. So we need here we'll have the front and the rear. Okay, the front and the rear, the front of the queue and the rear of the queue, or the front of the queue and the back of the queue. So you can use any name for that. So front and say rear. So one pointer stores the address of the node at the front of the queue. The other point stores the address of the node at the rear end of the queue. And list size. This is also important. So this is good enough. Then we need to have constructor for the CQ class and the destructor for the CQ class. Acha, push is basically NQ. NQ. Okay? We are going to enqueue a new node into the queue, and pop is basically DQ. Okay? DQ. Get size remains the same, is empty, is fine. Acha. We need to know what is the front. Okay? Front, let us call it capital front, front, and rear, and rear. Okay. So the value stored in the nodes at the front of the queue and the rear. We can add get front and get rear as well. Like we can make it as get front and get rear. Okay. So we can do it this way as well. Acha, ये हो गया. Now let us implement the cstack class. Okay, let us do this implementation. For that we need to add a source file. So let us add the source file. This is our source file. Shitty. We need to save it here. My classes.c++ and include it in the active project and then finish. So here we are. So let us include our declarations from my classes.h. Then we might need to do some printing. So let us include IOStream as well. We may and we may not. And using namespace std. Okay. So let us implement the cstack class. So this is going to be the constructor. Let us do the scope resolution. For every function. Sorry, let me copy this whole thing and let me paste it here. Then here, then here, then here, then here, and then here. ठीक है? अच्छा जी. Then we need to provide the bodies for these functions. Sure. Okay. So let's implement the constructor. So when a stack is created, it would be an empty stack. So the top would point to, top is basically t, variable t. T would be equal to null. T would be equal to null. Okay? This pointer t, it won't point to anything. T would be null, and list size would be 0. List size would be equal to 0. So this is how a new stack would look. It would be completely empty. Acha, what about the destructor, so we can postpone it later, but we can start it now as well. So again, just like the linked list, we need to access each and every element, and then we need to destroy that element. Okay. So for that, in order to traverse through the list, we need this pointer. Okay. Node current, and we need to set it to t, so we need to start from the top of the stack. Acha. Then the node that we want to delete, sorry, so it's, we call that as delete me. So we have been doing it for so many times now, and that is current. We start from the top. Okay. So while current is not equal to null, current is not equal to 0 or null, what do we do? So what we do is we say current is equal to current arrow next. This you should have memorized by now. And then we say delete, sorry, current is equal to current arrow next. Okay. Sure. So current is equal to current arrow next, and then we can delete the node that we have to delete. Delete me, and then the next node that we will be deleting is basically the new current node. Okay. So I guess this is the code that will delete all the nodes in the stack. Okay. This is done. Now, what about pushing an element into the stack? Pushing an element into the stack. So first of all, we need to create a new node. We are just getting the data. So node nn pointer to a node, and we are basically creating a new node. Okay. Acha. So the first thing that we need to do is we need to store this data. Nn arrow next, sorry, arrow data is equal to x. This is the value that we need to store in that node. अच्छा यहाँ देख लें. Let us look at this figure, the stack. Let us look at it and then see. So stack as a linked list. So let us look at this figure. So say for example, if we are trying to uh, insert a new node into a stack. ठीक है. So let us look at the possibility कि वो stack empty है. Initially the stack is empty. So when you insert a new node into an empty stack, that node would point to nothing, यानी उससे पहले there is no node, so it should be 0. ठीक है. And that node becomes the top node in the stack. ठीक है. So if the stack is empty, ठीक है, वो हमें कैसे पता चलेगा? If top या t, that is the top basically, if t is equal to 0, it is null. तो ये जो नया node है, so it will not point to, इसका जो next होगा, that would be nothing. This would be the first node in the list. This would be equal to null, and this would become the top node. ये हमारा top node बन जाएगा. ठीक है. T would be equal to the new node, so the new node would become the top node. ठीक है. अच्छा. If that is not the case, if the stack is not empty, there is already some node in it, फिर क्या होगा? उस केस को देख लें. So say अब ये situation है कि the stack is not empty and we want to insert a new node. So this is the new node. ठीक है. So ये वो नया node आ गया. This is new node. ठीक है. It has some data, say 6 or whatever जो भी है. Now when we are going to insert this new node, so this new node would become the new top, और ये जो हमारा पुराना वाला top है, this would become the next node. ठीक है. After this top, तो इस top के बाद फिर ये वाला node होगा. तो इस नए node में हमने data store कर लिया. इस नए node का जो next node होगा, that will be the current node, and then this new node will become the new top. So t should point to this node. ठीक है. अच्छा, दोबारा से सुन लें. चलें, वो हमने डिस्कार्ड कर दिया. लेट मी शो इट अगेन. से दिस इज द न्यू नोड दैट वी वांट टू इंसर्ट. जब न्यू नोड इंसर्ट होगी तो दिस वुड बिकम द टॉप नोड. ठीक है, एंड इसके बाद ये वाला नोड होगा जो कि मौजूदा टॉप है, द करंट टॉप. ठीक है. सो हमने क्या करना है, इस न्यू नोड में पहले डेटा स्टोर कर लिया, फिर इस न्यू नोड के नेक्स्ट में हमने मौजूदा टॉप नोड का एड्रेस कॉपी कर देना है ताकि वी शुड नो व्हाट कम्स आफ्टर द टॉप. Once we have done that, then we need to declare this new node as the top node. So t should point to this node. और वो कैसे होगा, हमने t में इसकी वैल्यू, इसका एड्रेस स्टोर कर देना. ठीक है. So let's do that. So else नए नोड का जो नेक्स्ट नोड होगा दैट वुड बी हमारा मौजूदा जो टॉप नोड है, और ये नया नोड फिर इट विल बिकम आवर न्यू टॉप नोड. ठीक है. द न्यू नोड विल बिकम द न्यू टॉप. And once we have pushed a new element onto the stack, just increment list size. ठीक है. We don't need to do anything else. ये हो गया. अच्छा जी. So we have implemented the destructor, the constructor and the push operation. ठीक है, हो गया. Now we have to do the popping off. अच्छा, अब वैसे तो if pop के लिए again we have the two scenarios. Scenario number one is कि the stack is empty, so you cannot pop anything off an empty stack. ठीक है. So this should return an error कि the stack is empty. Scenario number two is कि the stack is not empty. So say for example we need to pop this element. So pop करने के बाद क्या होगा, when we are going to pop off this element, इसको remove करना चाहते हैं. So what will happen? What will happen is कि this node will become the new top. ठीक है. This node will become the new top. The node that comes after the top node, that would become the new top. ठीक है. तो before deleting this node which is at the top, हमने इसका जो next वाला एड्रेस है इसको स्टोर करना है. क्यों? Because that is the address of the node which is going to become the new top. So इसको कहीं पे स्टोर कर लें, इसको डिलीट कर लें, फिर make it the new top. ठीक है. So it is that easy. And this is the situation when the stack is not empty. ठीक है. तो when is the stack not empty? So if top is not equal to 0, that means the stack is not empty, then we want to execute this code. ठीक है. Otherwise we don't need to execute this code. अच्छा, इस कोड में सबसे आखिर में हम वो लिस्ट साइज को डेक्रीमेंट करेंगे, जस्ट इन केस यू आई फॉरगेट. सो वो पहले मैं लिख लेता हूँ. अच्छा, होगा क्या, हमने जिस नोड को डिलीट करना है वी नीड टू स्टोर इट्स एड्रेस. सो डिलीट मी, दैट इज़ द एड्रेस ऑफ द नोड जिसको हमने डिलीट करना है. और वो नोड कौन सा वाला है? Deletion has to take place from the top. That is basically the top node t, जिसका एड्रेस t में है. So we have to delete this node. उसको मैंने यहाँ बैकअप पे कर लिया. अच्छा, what we need to do is we need to declare the new top. T is equal to the new top is t is equal to t arrow next. पुराना जो top है उसका जो next node होगा that would be the new top. अच्छा, अब मैं यहाँ पे delete t नहीं कर सकता, so that is why I stored the value of t before changing t. ठीक है. So now previous जो top था उसका एड्रेस मेरे पास यहाँ पे पड़ा हुआ है. So all I need to do is I need to say delete me. So वो नोड delete हो जाएगा. ठीक है. That's it. This is how the pop operation works. ठीक है. अच्छा, return get size should return the list size. Return list size is empty. ठीक है. So ये क्या करे, it should return t equal to 0. If the pointer to the top node, if that is null, we are comparing it with 0. If it is null, if it is true कि वो null है तो true की value आएगी, stack is empty. If it is false तो फिर वो false की value आएगी. अच्छा, here we want to return the top element, उसकी value क्या है. ठीक है. So we want to return that. So if अच्छा, अब यहाँ पे दिस इज ऑल्सो ट्रिक, इफ द स्टैक इज एम्प्टी एंड यू कॉल द टॉप फंक्शन, फिर क्या होगा? तो फिर दैट शुड थ्रो एन एरर। अब हम यहाँ पे फिर फिलहाल फॉर सिंप्लिसिटी एज्यूम कर रहे हैं कि दिस मेथड वुड बी कॉल्ड ओनली व्हेन द स्टैक इज नॉट एम्प्टी, ठीक है? तो ये उस वक्त कॉल हो रहा है। तो लेट्स सी इफ वी कैन, अच्छा, so if t is not equal to, if t is not equal to 0, if t is not null, ठीक है? so then क्या करें? then करें जी return return t arrow data, ठीक है? so then return the data stored in the node at the top if it is not equal to 0. If it is equal to 0, फिर क्या हो? Then we have to say that this is an error, basically we have to throw an exception. तो उसकी यहाँ पे there is no, यहाँ पे कोई उसकी गुंजाइश हम फिलहाल नहीं रख रहे। Otherwise we can go back to the other implementation के जिसमें हम कहेंगे जी top should return boolean value. If the top exists it should return true, और यहाँ पे we should have an argument by reference, और उसमें हम उसकी वैल्यू रिटर्न करते हैं, ठीक है? तो फिलहाल हम एज्यूम करेंगे कि दिस फंक्शन वुड बी कॉल्ड whenever the stack is not empty, or if it is called for an empty stack, so we are going to return a very odd value, ठीक है? minus say 99999, so this is a very odd value जिससे पता चलेगा कि जी stack is empty, ठीक है? but you should understand कि मैं क्या कह रहा हूँ और उसके implications क्या हैं. So this is basically the implementation of the stack data structure, ठीक है? This is the implementation of the stack data structure. Now let us test the stack data structure. I'm not sure that we would have enough time to implement the queue data structure as well. So I want to test the stack data structure at least. Maybe the queue data structure you can implement by yourself. After all, it's not that difficult. Okay? It's exactly the same way. Sorry, my classes. More or less the same way. Okay? So you need to practice it. So let us create a stack, C stack, and let us call it as S, ठीक है? अच्छा जी, अब क्या करें? S में let us push data onto the stack. अब इसमें we don't have the print function, we did not include that, so हमें we won't be able to look at the stack, बस सिर्फ top का पता चलेगा, ठीक है? So what if we provide a print method as well? Let us add a print method as well, ठीक है? Print method as well. So ये तो Q class है. Let us go to the C stack class and let us add a print method as well here. Say void print. So this is going to print the stack. अच्छा जी, let us come here. So here we are going to implement the print method. So it doesn't make any sense to have a print method in the stack class, but I want to visualize it, ठीक है? तो stack उसको visualize करने के लिए we are providing this print method. So again we have to visit each node in the stack. So this is equal to say t, and while current is not equal to 0. So what do we want to do? We want to visit each node in the stack, ठीक है? By visiting we mean we want to print its value. So we want to say cout current arrow data, and then after that we are printing this arrow symbol, ठीक है? And अच्छा, so this is what we are doing, current arrow data and then this arrow symbol, then we say current is equal to current arrow next, ठीक है? and once we are done with it, we just print out an n-line character, and we can print a message here, traversing the stack. We are traversing the stack. अच्छा जी. Okay, so we are traversing the stack, and this is how we are traversing it. So let's see. Let's use this code. So again, let us use a loop for int I is equal to say 1, I less than 10, and then plus plus I. So let us push elements onto the stack. Okay, so s dot push. So what are we pushing here? I onto the stack. Okay, or I square, whatever you want here. So yeah, 2 times I multiplied by 2, say we are pushing that onto the stack. Once we push it, we want to print the stack. Okay. We want to print the stack, and we want to print the top element of the stack. Okay. So cout top of the stack is, and we want to get the top element s dot top. Okay. And then the end line character. Okay. So this is what we want to do. Acha. Once we have done that, say then we want to do the reverse. So then we want to say to this thing, we want to say s dot pop. We want to pop elements of the stack. Then we want to print it, and then we will see what is the top of the stack. Okay, and let us make it say 9. We don't want the stack to go empty. Acha ji. Let us build and run it. So compile and then build and run. Okay, so what does it say? Invalid use of member top const. Did you forget this? Okay, what are we doing here? Okay, top, it's T basically. Okay, this is basically T. Sure. Okay, let's do it again. Compile, build and run. Okay, so the output is quite a lot. Like, so we created the stack S, then we started pushing data onto it. So the first data that we pushed onto it was 2 times 1, 2. So 2, that is what the stack, this is the top of the stack. Top of the stack is 2. Acha. Then again we push 4. We say traversing the stack, so 4 is now at the top. So 4, then after 4 we have 2. So top of the stack is 4. So we are inserting new nodes into the stack, and that new node appears at the top of the stack. See, 6, then 8, then 10, 12, 14, 16, 18. फिर चलते चलते it goes up until अच्छा 18. अच्छा, so then we stop at 18. फिर हम क्या करते हैं, we start popping data off the stack. ठीक है, so we pop one item off the stack, one node off the stack. So top of the stack 18 था, तो जब 18 को हमने pop off कर दिया, तो now 16 which came after 18, now that is the top. ठीक है, फिर we popped off another item, 16 को भी pop कर दिया. So next the stack is basically the top of the stack is 14. फिर हमने 14 को pop off कर दिया, and then we have 12, फिर 10, फिर 8, then 6 4 then 2. ठीक है, so उसके बाद हमने बंद कर दिया. ठीक है, what happens if we run it say till 10? So it will create some problem for us. Let's see कि वो क्या problem बनती है या नहीं. s.pop maybe now maybe हो. Let's see. So again, top of the stack is minus, so the stack becomes empty. So after the last element is popped off, the stack becomes empty. And when you call the method top of the stack, so it returns you this invalid value. Okay, that is basically going to signal k. This operation should not have been called or invoked. Okay, so this is how you can implement the stack data structure using linked lists. Similarly, we can also implement the queue data structure using a linked list. So in that case, you will need two pointers. So we will have two pointers like this. So we'll have the front and the rear pointers. So the first element that we are going to insert or enqueue, so that is going to be both the front and the rear. And after that, new insertions will keep on changing the rear pointer, but the front pointer that will remain unchanged. So you can think about implementing the queue data structure using linked lists in C++. Okay, so I hope it won't be that difficult. We don't have time to do that in this session. If I have time, I will do that implementation and share the video with you, but I'm not sure whether I would be able to find that time or not. So until then, Allah Hafiz.